everyone, welcome to the live session for Structure, Form and Architecture, The Synergy. This is an NPTEL course and the course instructor for this course is Professor Shubhajit Sadhu Khan. He is a professor at IIT Roorkee right now. I am Shreya Shukla. I am currently doing my PhD from IIT Roorkee and I am the NPTEL course TA for this course for this semester. So in these live sessions, we do previous year questions where answers to some previous year assignments are given along with some explanations. And these sessions are organized so that you can have a better understanding of the course. And if there is any doubt, you can always ask those doubts. So today we will be doing week 5 and assignment 5 of week 5, and there would be around 15 to 20 questions in each live sessions. Yes, so without any further ado, we will start with the session. So firstly, we will start with the most important thing, the terms of the course. So there are 4 terms in the name of the course, which are structure, form, architecture and synergy. And I would quickly explain what all these terms mean. So structure in architecture, structure has a lot of meanings in different contexts. But in architecture, it refers to the system which is used to support and transmit possible loads on the building onto the ground. It gives stability and it also resists stresses and strains. So in terms of architecture, it is a system which is used to support the loads on the building to the ground. What is form? Again, form has different meanings in different contexts. But in terms of architecture, a form is supposed to be a 3-dimensional object or building that is perceived by a viewer in space and time. And it is made possible through the action of light and shadow. So basically any 3D object or a building which can be visually perceived by a person in space and time is what a form is. And the form is recognized or it has been made possible by the action of light and shadow. Architecture. So architecture is the art and technique of designing and building. And what is synergy? Synergy is not just amalgamation. Synergy is bigger than amalgamation in the sense that the interaction or cooperation of 2 or more agents, substances, organizations to produce a combined effect greater than the sum of their separate effects. For example, there are 3 entities and you add their effects. So synergy, basically when you amalgamate all those 3 things together, so the combined effect would be much more than the individual effects when they are added. So this is what synergy is, that when you combine or the interaction between 2 or more agencies or entities, the combined effect is greater than their individual effects. So this is what synergy means. So this course is entirely about the synergy of structure, form and architecture. So now the syllabus for week 5 is framed structures, arch structures, vault structures, dome structures and grid structures. So this is the syllabus for week 5, in which details will be discussed about frame structures, arch structures, vault structures, dome structures and grid structures. These topics would be discussed from the structure point of view, and also typologies will be discussed, and also different inserts from the history will also be discussed here. Starting with the session now. Question number 1. A wedge-shaped or tapered stone used to construct an arch is called crown, voussoir, keystone or extradose. So crown is considered to be the highest point of the extradose, or it is the highest part of the arch. So In any arch, there are two parts. The inner part is called the inner circumference is called the intrados, and the outer circumference is called extrados. So, the crown is the highest point of the extrados, or it is the highest point of the arch. What is a voussoir? A voussoir is a wedge-shaped stone which is used in building arches and vaults. If you are building an arch or any other curved shape, rectangular bricks cannot be used. So they have to be wedges because rectangular bricks cannot be used to create arches. So each voussoir or each wedge-shaped stone which is used to build arches, it should be precisely cut so that it presses firmly against the surface of the neighboring blocks and it transfers the loads uniformly. The central voussoir is called the keystone. So the voussoir at the crown or at the center is called a keystone, and the point from which the arch rises from its vertical supports is known as the spring or springing line. During construction of an arch, the voussoirs require support from below until the keystone has been set in place. This support usually takes the form of temporary wooden centering. So as you can see in the image, all the wedge-shaped stones or bricks that are used in building the arches are called voussoirs. What is keystone? As mentioned in the previous slide, the wedge-shaped unit which is fixed at the crown of the arch is called a keystone. Now what is a crown? Crown is the topmost point of the extrados. A keystone is also called a capstone or the wedge-shaped stone at the apex of the masonry arch, or typically round-shaped one at the apex of a wall. In both cases, it is the final piece which is placed during the construction and it locks all the stones into position, allowing the arch or vault to bear weight. In arches and vaults, such as Qazi domes, keystones are often enlarged beyond the structural requirements and decorate. What is extrados? Extrados is the outer surface of an arch or the outer curve of the arch ring. And the opposite of extrados is intrados. It is the inner surface of an arch or the inner curve of the arch ring. So extrados is the outer curve of the arch ring. The highest point in the extrados is called a crown. The different wedge-shaped stones or bricks that are used to make the arch are called voussoirs, and the voussoir at the center or at the crown is called a keystone. The keystone is fit in at the last and it is the final piece that is placed during construction and it locks all the stones into position. Keystones are often enlarged beyond the structural requirements and they are often decorated also. So this image shows the different parts of arch. We have a crown here, we have intrados and extrados, the depth of arch, the spring line, the span and the abutment. All these points are shown in this image and you can see. And also the rise. So the answer is voussoir. The wedge-shaped or tapered stone which is used to construct an arch is called voussoir. Question number 2. Columns and beams are made monolithically and acting together to tolerate the moments created due to imposed load on structure. Pneumatic structure, folded plate structure, rigid frame structure or braced frame structure. So the question is asking that in which type of structure the columns and beams are made monolithically and acting together to tolerate the moments created due to imposed load on the structure. So starting with the first term, pneumatic structure. What is a pneumatic structure? A pneumatic structure is a membrane structure and it is stabilized by the pressure of compressed air. Pneumatic structures are characterized by a slightly higher pressure of internal air above the outside pressure. These structures are supported by pressurized air within the inflated building elements, which are shaped to carry loads in a traditional manner. The roof membrane of the pneumatic structure is made from rubber or reinforced films using industrial fabrics coated with polymers. For example, one of the fabrics that is used is called ETFE. So in pneumatic structures, it is a membrane structure and it is stabilized by the pressure of compressed air. The pressure of air inside the structure is higher than the pressure of air outside the structure. And the roof membrane of these structures is made from rubber or reinforced films. And yeah, there are two types of pneumatic structures. One is in which one is the inflated one, and one is the one, I'm forgetting the name for it, but I would, if I remember it, I would mention it in the end of the session. Then folded plate structure. So folded plate structures are necessarily the assemblies of flat plates or slabs which are inclined and in different directions and joined together along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need of additional supporting beams along the mutual edges. So basically what happens in folded plate structures is that different slabs of different, uh, they are joined together in different directions at in their longitudinal edges, and it creates a fan-like structure, you can see, or a structure which is, it is basically joined at an inclined shape. If you can see in the image, you can see the zigzag pattern that folded plate structure is creating. This technique originated in Germany in the 1920s, and it became popular to construct roofs for industrial warehouses and public buildings. Modern folded plate structures are typically made of cast in situ or precast reinforced concrete or steel plate. Rigid frame structure. So a rigid frame system consists of linear elements like beams and columns. The word rigid means ability to resist the deformation. It is used in steel and reinforced concrete buildings. Rigid frames are characterized by the lack of pinch joints within the frame and typically statically indeterminate. A rigid frame is capable of resisting both vertical and lateral loads by bending of beams and columns. Stiffness of the rigid frame is provided mainly by the bending rigidity of beams and columns that have rigid connections. So the rigid frame structures, they consist of linear elements, basically the beams and columns. The word rigid means to able, the ability to resist the deformation. And rigid frame structure is used in steel and reinforced concrete buildings, and they are characterized by the lack of pin joints within the frame because the joints are usually rigid joints and typically statically indeterminate. It is capable of resisting both vertical and lateral loads. What are braced frame structures? Braced frames are composed of beams and columns that are pin connected with bracing to resist lateral loads. This type of frame is simple to analyze and simple to construct. The resistance to lateral forces is obtained through both horizontal and vertical bracing. Many types of bracing can be used. For example, knee bracing, diagonal bracing, X bracing. For example, in the image, X bracing is provided, K or chevron bracing, shear walls that resist lateral force in the plane of the wall. This frame system provides more efficient resistance against the earthquake and wind forces. It is more effective than rigid frame systems. So basically, braced frame systems are composed of column beams that are pin connected with the bracing. So there is a column beam system, but that column beam system is pin connected with a bracing system, and these braces are usually connected to provide extra resistance to lateral forces, and this is very efficient in earthquake and wind against wind forces. So the answer is rigid frame structure. In rigid frame structures, columns and beams are made monolithically and acting together to tolerate the moments created due to imposed load on structure. Question number 3. An arch with a straight horizontal extradose is called as camber arch, lancet arch, augie arch, catenary arch. So the question is asking that the extradose is horizontal in an arch, and what is that type of arch called in which the extradose is horizontal. So I have added explanation of all the 4 types of arches mentioned, and also added images of all the 4 types of arches mentioned. So camber arch, it is an arch whose intradose, though apparently straight, has a slightly concave curve upward, but the extradose is completely straight. So you can also call it a flat arch. So the extradose of camber arch is flat or a straight line. However, the intradose, it may appear to be straight, but it has a slight curve upwards. So this is what a camber arch is. Lancet arch is a variety of pointed arch in which each of the arcs or curves of the arch have a radius longer than the width of the arch. So basically, lancet arch means that the radius so the radius of the curves that are a part of the arch is longer than the width of the arch, which creates a pointed arch. So this is what a lancet arch is. In augie arch is all S curves are there, and it's a 4-point arch, which means that the curves have there are curves with 4 different centers. It is formed by the intersection of 2 S curves, which are usually confined to decoration, and they are not used in arcade arches. Augie arches were used in the late Gothic period. They are also used in Islamic architecture. So augie arch has 4-point centers. So there are 4 curves, 2 S curves, and 4 centers of curves, 2 of which are outside the arch and 2 of which are inside the arch. Catenary arch, it is a type of architectural arch that follows an inverted catenary curve. So our answer is camber arch. Camber arch is an arch with a straight horizontal extradose. The intradose may appear straight, but it is slightly curved towards upwards. But the extradose in a camber arch is straight horizontal. So an arch with a straight horizontal extradose is called as camber arch. Question number 4. A dash is a continuous arched shape that may approximate a semi-cylinder in form. Annular vault, barrel vault, Catalan vault or fan vault. A dash vault is a continuous arched shape that may approximate a semi-cylinder in form. So we will see what all these four vaults mean. So before explaining annular vault, I will explain what is barrel vault. So barrel vault is a continuous arch shape that may approximate a semi-cylinder in form, which resembles the roof of a tunnel or may be pointed at its apex. It is typically formed by a series of arches. Barrel vaults must be able to withstand the outward pressure on the lower parts of the vault imposed by the structure above. So in barrel vaults, it is a continuous arch shape and it may approximate a semi-cylinder in form. Basically, it's like a semi-cylinder cut vertically. So, and what annular vault is? Annular vault, it is a kind of barrel vault, but in the shape of a ring. So, a barrel vault is, for example, barrel vault is an arch extended in a straight line. An annular vault is an arch extended in a circle. So, example of annular vault is in Colosseum, Rome, and I have added pictures here also. So, the first picture is annular vault, and the second picture is barrel vault. Annular vault is a barrel vault in the shape of a ring instead of straight line, which covers a space of which the plan is formed by the area between two concentric circles or any portion of such a space. So this is what annular vault and barrel vault is. A barrel vault is a continuous arch shape which may approximate a semi-cylinder and in the form resembling the roof of a tunnel. And in annular vault, it is a kind of barrel vault in the shape of a ring instead of a straight line like a barrel vault, and it covers a space which is formed by the area between two concentric circles. Catalan vault. A Catalan vault is a type of low brickwork arch which is formed by forming a vaulted ceiling that often supports a floor above. It is constructed by layering a first layer of light bricks lengthwise in space without centering nor formwork, and it has a much gentler curve. Fan vault. A fan vault is informed by a series of concave sections or ribs that spread out from a series of spring points. The ribs of a fan vault are of equal curvature and rotated at equal distances around a central vertical axis. It is mostly used in Gothic architecture. So a fan vault is formed by a series of concave sections or ribs that spread out from a series of spring points. The ribs of a fan vault are of equal curvatures and they are rotated at equal distances around a central axis. So the answer is barrel vault. Barrel vault is a continuous arched shape that may approximate a cylinder in form. Question number 5. The vault type used in Great Mosque of Cordoba is barrel vault, cloister vault, rampant vault or rib vault. So this is the Mosque of Cordoba. The architectural style is Islamic architecture and Gothic architecture. The architects were Hernan Ruiz the Younger, Hernan Ruiz III, Hernan Ruiz the Elder, Diego de Ochoa Prates, Juan de Ochoa Prates. It was opened in 988 AD. It is located in Cordoba, Spain, and the function is a cathedral which was a mosque previously. So this is some of the images from the Cordoba Cathedral or Cordoba Mosque. And this is another image from there. And then I would explain the terms that have been mentioned in the question. So first is the barrel wall, as explained in the previous question. Uh, it is a continuous arched shape that may approximate a semi-cylinder in the form uh, resembling the roof of a tunnel, which may be pointed at an apex. It is typically formed by a series of arches, and barrel walls must be able to withstand the outward pressure on the lower parts of the wall imposed by the structure above. Cloister vaults, also known as dome vaults, are dome-shaped vaults that maintain a polygonal shape in their horizontal cross section. They arch towards the center from a constant spring point along a wall. They are known as dome vaults because they look like they had inspired by, they have a very huge resemblance with the dome, and they maintain a polygonal shape in their horizontal cross section. Rampant wall. Rampant vault is a continuous wagon wall or a cradle wall where two abutments are located on an inclined plane, such as the wall supporting the stairway or forming the ceiling of a stair. The impost on one side is higher than the impost on the other side. So what happens in a rampant vault is that the two posts or the two abutments which support the vault, they are located at different planes or different heights. What this means is that this vault becomes an inclined vault in the sense that the one impost is higher than the other impost, which creates inclined vault, and it is usually under the staircase, or it forms the ceiling of a stairway. So that is what a rampant vault is. Rib vault. A ribbed vault or ribbed vault is an architectural feature for covering a wide space such as church nave, composed of a framework of crossed or diagonal arched ribs. The crossed arch domes is one of the earliest types of ribbed vault, formed where the ribs, instead of meeting in the dome's center, are intertwined to form polygons, leaving an empty space in the center. So the answer is rib vault. I will check with this answer once. I have a doubt in this answer. Next question number 6. Dash is any building with a circular ground plan covered by a dome. So yes, the correct answer of question number 5 is rib vault only, and 4 innovative ribbed vaults were built in the extension of the Mosque of Cordoba. The pattern of crossed arch vaults, together with the early and systematic use of ovals for the ribs, make them a unique case of research. So the answer is rib vault. They have innovative rib vaults, crossed arch walls, and innovative rib walls in that. So dash is any building with a circular ground plan covered by a dome. A coffer, B rotunda, C squinch, D pendentive. So coffer in architecture is a series of sunken panels in the shape of a square, rectangle or octagon in the ceiling, soffit or vault. So a coffer is basically, you can say coffer is also called waffle slabs. Coffer slabs are also called waffle slabs. But in terms of architecture, it is a series of sunken panels in the shape of a square, rectangle, octagon in a ceiling, soffit or vault. One of the most famous buildings which have a circular coffer slab is the uh, Pantheon in Rome. Now rotunda. A rotunda is any building which has a circular ground plan and it is sometimes covered by a dome. It may also refer to a round room within a building. Squinch. A squinch is a triangular corner that supports the base of a dome. Its visual purpose is to translate a rectangle into an octagon. So the visual squinch is used for a visual purpose to translate the rectangle into an octagon to support the dome above a square room. However, in pendentive, a pendentive is a constructional device which permits the placing of a circular dome over a square room, of an elliptical dome over a rectangular room, with the help of this way of construction. So in a squinch, basically already there is a square room and then squinches are added there and then the dome is supported there, and the addition of squinch creates an octagon which supports the dome. But however, in pendentive there is supposed to be a square room, but the upper part of the columns is curved and then constructed in such a way that it supports the dome. So the answer is rotunda. A rotunda is any building with a circular ground plan covered by a dome. So this is an example of a rotunda with coffer slabs, and it also has an oculus in the center. This is from Parthenon, Rome. Question number 7. Metropole parasol in Italy is an appropriate example of grid structure, arch structure, cable suspended tensile structure, pneumatic structure. So this is what the Metrosol parasol looks like. What is a grid structure? A grid is a structure, usually two-dimensional, made up of a series of intersecting straight, vertical, horizontal and angular or curved lines. It provides a more structural stability without using a lot of additional material. Arch structures. In architecture, an arch is an opening in a structure that is curved on top and designed to distribute weight. Arches are self-supporting compressive structures, and it is stabilized by the force of gravity acting on their weight, which makes them very stable and efficient, capable of larger spans and supporting greater loads than horizontal beams. Cable suspended tensile structure. A suspended structure is a structure which is supported by cables coming from beams or trusses which sit atop a concrete center column or pole. The design allows the walls, roofs, and cantilevered floors to be supported entirely by cables and a center column. Pneumatic structure. Pneumatic structure is a membrane structure which is stabilized by the presence of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. The answer is A. Grid structure. Metropole parasol in Italy is an appropriate example of grid structure because, as you can see in these images, it is a curved grid structure. It is a grid structure, but a curved grid structure in which there are intersecting parallel lines intersecting each other at right angles. Question number 8. A straight or arch structure across an interior angle of a square tower to carry a dome is called as oculus, tholobate, squinch, pendentive. Oculus is a circular opening in the center of a dome or in a wall. It is originating in antiquity. It is a feature of Byzantine and neoclassical architecture. A tholobate or drum is the upright part of a building on which a dome is raised. It is generally in the shape of a cylinder or a polygonal prism. Squinch is a triangular corner that supports the base of a dome. Its visual purpose is to translate a rectangle into an octagon. A pendentive is a constructional device permitting the placing of a circular dome over a square room or of any elliptical dome over a rectangular room. So the answer is squinch, a straight or arch structure across an interior angle of a square tower to carry a dome is called as squinch. Question number 9. Which of the following dome type was used in Saint Sophia Cathedral in Novgorod? Umbrella dome, saucer dome, oval dome, onion dome. So this is the Novgorod Cathedral. It's located in Kremlin Park, Novgorod Oblast, Russia. The architectural style is architecture of Russia. It was opened in 1050. The height is 38 meter and there are 5 domes on it. So explaining the 5 terms mentioned in the question. Umbrella dome. It is also known as a ribbed dome or a parachute dome or a scalloped dome. These are divided into curved segments that follow the elevations curve. Radial lines of structure that act as dome's ribs extend down the springing from the apex. Saucer dome, a dome that is less than a hemisphere in form or that shows less than a hemisphere on the exterior is called a saucer dome. Oval dome, an oval dome may be defined as a dome whose plan or profile both has an oval form. Onion dome, onion dome is a dome whose shape resembles an onion. Such domes are often larger in diameter than the tholobate upon which they sit, and their height is usually exceeds their width. It is a common feature of Russian architecture. So the answer is onion dome. The dome type which is used in the Saint Sophia Cathedral in Novgorod, Russia is onion dome. Going back to the image, you can see how these domes are onion shaped domes. So the answer is onion dome. Question number 10. Which of the following building used diagrid structure for its construction? Burj Al Arab, Swiss Re 30 St. Mary Axe or the Gherkin, Willis Tower Chicago, Burj Khalifa. So what is a diagrid structure? A diagrid, which is a portmanteau of diagonal grade, it is a framework of diagonally intersecting metal, concrete or wooden beams that is used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. Hearst Tower in New York, which is designed by Norman Foster, it uses 21% less steel than the standard design. The diagrid obviates the need for columns and can be used to make large column-free expanses of roofing. So now the four buildings that are mentioned in the question: Burj Al Arab, Swiss Re 30 St. Mary Axe or the Gherkin, Willis-Star Chicago, Burj Khalifa. So the answer is Swiss Re 30 St. Mary Axe or the Gherkin, because as you can see it uses a diagrid structure. The Burj Al Arab uses raised frames. Willis Tower Chicago and Burj Khalifa both use bundle tube structures. The answer is Swiss Re 30 St. Mary Axe. It uses a diagrid structure for its construction. It's a curved diagrid structure, but it's a diagrid structure. Question number 11. Which of the following is not true for a frame structure? Thickness of wall can be maintained. Construction of frame structure is speedy. Utilization of space is flexible. Prefabrication is not possible. So a frame structure is a structure having the combination of structural components, that is beam, column and slab, connected together to resist the gravity and different lateral loads, capable to overcome the large forces, moments developing due to applied loads. The imposed loads on slab beam transfer through beam and then column to lower floor and eventually to foundations to the soil. The thickness of wall can be maintained uniform throughout, and considerably thinner wall reduces dead load. Due to simple geometry, it consists of beam and columns. Construction of frame structure is very speedy. Rigid and stable frame structure could be able to resist tremendous vertical and lateral loads. Vertical load as in the dead load, lateral loads like the seismic load. Large unobstructed spaces can be achieved with frame structure, and utilization of space is flexible. It is adaptable to almost any shape and can be used for high-rise structure as well. Prefabrication is possible to make the construction easy. So the answer is, the question was asking which of the following statement is not true. So since prefabrication is also possible in frame structures, the statement D is not true, which is prefabrication is not possible in frame structures. Question number 12. Which of the following is an example of grid structure? Coffer slab, funicular arch, geodesic dome, space frame. So coffer slab is a ribbed structure with reinforced ribs in the lower zone which have mutually perpendicular arrangements. Funicular arch structures include the parabolic arch, tunnel vault and dome, which act in pure compression and which have a rise to span ratio of 1:10 to 1:2. Geodesic dome is a hemispherical thin shell structure based on geodesic polyhedron. The triangular elements of the dome are structurally rigid and distribute the structural stress throughout the structure, making geodesic domes able to withstand very heavy loads for their size. Space frame. A space frame or space structure is a rigid, lightweight, truss-like structure constructed from interlocking struts in a geometric pattern. Space frames can be used to span large areas with few interior supports. So the answer is coffer slab. Coffer slab is an example of a grid structure. Question number 30. Which of the following is not an arch type? Lancet, camber, ogee or focal? So camber arch, as explained previously, it has an intradose which has a slight curve, and the extradose of camber arch is completely horizontally straight. In lancet arch, the arch is a variety of pointed arch in which each of the arch curves or the arch have a radius longer than the width of the arch. And in ogee arch, there are two S curves which form this arch, and it is not used in arcade arches. It was usually used in Gothic period and Islamic architecture. So the answer is focal. Focal is not a type of arch. Question number 14. A continuous vault having two abutments located on an inclined plane is. So the answer is rampant vault. In a rampant vault, a continuous wagon vault, it is also called a continuous wagon vault or a cradle vault, whose two abutments are located on an inclined plane, such as the vault supporting a stairway or forming the ceiling of a stairway. The impost on one side is higher than the impost on the other side. So the answer is rampant vault. A continuous vault having two abutments located on an inclined plane is a rampant vault. Question number 15. Meridional stress developed on a dome is dash in nature: compressive, tension, bending or shear. So the analysis of a shell or a dome is concerned with two types of stresses: the stresses that act on the meridional direction and the stresses that act in the parallel direction or hoop. So the stresses that act on the meridians, which is the top of the dome to the bottom circumference of a dome, are compressive in nature. However, the stresses that occur on the hoops or the concentric circles are both compressive and tensile in nature. So the meridional forces in a dome are compressive in nature, and the hoop stresses are both compressive and tensile in nature. So the answer is meridional stress developed on a dome is compression in nature. It has compression in nature, or it is compressive. Question number 16. The constructive device which allows the placement of circular dome over the square room is called squinch, oculus, pendentif, holobate. So as mentioned in the previous questions, that a oculus is a circular opening in the center of a dome or in a wall. A holobate or a drum is the upright part of the building on which a dome is raised. It is generally in the shape of a cylinder or a polygonal prism. A squinch is a triangular corner that supports the base of a dome. It has a visual purpose, and it is to translate the rectangle into an octagon. A pendentif is a constructional device which permits the placing of a circular dome over a square room or of an elliptical dome over a rectangular room. So the answer is C, pendentif. The constructive device which allows the placement of the circular dome over the square room is called pendentif. Question number 17. What kind of rigid frame structure is the example shown below? Fixed-ended, pin-ended, roller support or braced support. So this image has been given in which a structure is shown, and you are supposed to answer that what kind of rigid frame structure is the example shown below. Roller supports are free to rotate and translate along the surface upon which the rollers rest. Roller supports are commonly located at one end of long bridges. This allows the bridge structure to expand and contract with temperature changes. The expansion forces could fracture the supports at the banks if the bridge structure was locked in place. Roller supports can also take the form of rubber bearings, rockers, or a set of gears which are designed to allow a limited amount of lateral movement. So basically in roller supports, they are free to rotate and they are also allowed to move along the surface, which is that they are allowed to move horizontally. Fixed supports, they resist horizontal and vertical forces as well as the movement, and they restrain both rotation and translation. That is why they are known as rigid supports. This means that a structure only needs one fixed support in order to be stable. All three equations of equilibrium can be satisfied. A flagpole set into a concrete base is a good example of this kind of support. A pinned support can resist both vertical and horizontal forces but not a moment. They allow the structural member to rotate but not to translate in any direction. The knee can be idealized as a connection which allows rotation in only one direction and provides resistance to lateral movement. So this is the example. First is a fixed support of a pole and concrete. Second is a pin support in which rotation is allowed but no translation. And third is a roller support in which translation and rotation both are allowed. So coming back here to show the image, to give a summary of it, fixed supports allow movement in no direction, restrict movement in vertical, horizontal direction and also rotation. Pinned support allow movement in rotation about the supported location but restrict movement in vertical and horizontal direction. Roller support allow movement in horizontal direction and rotation about the supported location, but they restrict movement in vertical direction. Fixed ended is shown like this, pin ended is shown like this. So coming back to our answer, the answer is the rigid frame that is shown in this image is pin ended. So that is all for the session. If anybody has any doubts, they can ask in the live sessions. This is what the live sessions are for. So yeah, I would wait in the session for a while to see if anybody has to ask any questions, and then I will end the session. So this has been all for this session, and we covered total 17 questions in this session. I would quickly go through the PPT once more. So this is it for today, and all these PPTs will be made available to you by NPTU via a link. These sessions will also be uploaded on YouTube, and you can access these sessions from the YouTube link that will be provided to you. All the best, and this is all. Thank you.